user interface. So you can do NLRI injection with that tool. You can inject routing information into some BGP domain. There is also a module for EIGRP, which, as I said, will not be released now. Maybe in the future, not quite sure yet. But with that module, you can also inject EIGRP type length values, which are in fact routing information. And I also implemented 2 older attacks against EIGRP, which are the authenticated and unauthenticated denial of service attacks. And then there are 2 modules for HSRP and HSRP version 2, which is just a hot standby protocol for IP addresses, and with the Loki tool suite you're able to take over one of these IP addresses. So there is another module for the LDP, the so-called label distribution protocol, which is used within big MPLS backbone networks. You can hook into the LDP process and can inject label mapping messages. You're also able to attack some layer 2 over MPLS tunnels and establish your own tunnel and all that fancy stuff that LDP is able to. If you want to go deeper into all the LDP and MPLS stuff, I recommend you to take a look at our last year Black Hat talk about exactly that topic. That topic, which covers LDP, BGP, and MPLS. So there is an MPLS module as well, which can rewrite the MPLS labels, which also can discover different MPLS traffic paths. And there is also, like Rennie said, the MPLS TON program, which gives you or your machine some kind of MPLS VPN-enabled network stack. So you just pop up a virtual tunnel interface, when all traffic that you put into that tunnel interface will be MPLS labeled and thrown out to the network. Okay, there is an OSPF module. With this OSPF module, you can hook up into an OSPF routing process. You can inject OSPF routing information and also implemented an OSPF MD5 authentication cracker. So even if you're, but okay, you will see later on. We will have a nice demo on this one. I wrote a RIP module. This was more like some kind of typing lesson. It wasn't that hard. RIP is a really easy protocol. You can do route injection with that as well. You don't have to do any handshake, so just throw the routes on the cable and they will get into the routing table. Okay, there is a TCP MD5 module with which you can crack the RFC 2385 TCP authentication option, so which is mainly used by BGP and LDP for authentication for authenticating the neighbors. So if you see one of these packages, you can also do a wordless or brute force cracking on the password. There are 3 more modules, which is the VRRP and VRRP v3, which are also for IP address, hot standby, and fast handover. So you can just take over one of these hot standby IP addresses as well. And there is the WLCCP module, which was the main part of our last Black Hat talk in Europe this year, which is the wireless LAN context control protocol, which is also a Cisco proprietary protocol for building up a wired distribution system. And we take some work into analysis this protocol and do some crypto analysis on the authentication mechanism, and it came out that it's all based on LEAP authentication, and as you all should know, LEAP isn't really secure. So in the end, if you use this module, you will get the pairwise master key of wireless clients. Okay, Loki also has a graphical user interface. It's based upon GTK. I'm using PyGTK because it's really easy to program in Python, and I don't like GTK on the C interface. It's a pain in the ass. The main program has some hard-coded GTK window routines, which are, the main window, there is a configuration window, there's a log window and stuff like that. But the modules themselves, I decided to use Glade for the task, because with Glade you can easily design your interface and click a button here, click some input line there, and afterwards you will get a nice XML file, and that will be passed on runtime. But that means also that you can change your module GUI on the runtime. Or, let's say on the runtime of the main program, you always have to reload the whole module to get the new graphical user interface. But it's really easy to involve all your modules, as they can be reloaded on runtime. And so it's really easy to fix some bugs or do some testing and put in some new code. Okay, this is a nice screenshot of Loki, but you will see it in action in a second. Okay, I will hand over to Rennie again.
This one.
This one. Oh, yeah.
Thanks. So as Daniel, as you can see, there are lots of attacks implemented already in different modules. Some of them we will cover today. For some of them we will have nice demos, should be 4 in total. Others we won't cover because they were already covered in other talks, and which are just integrated to have a more usable tool. So we told you lots of, we have that module, we have that module, we have that module, but okay, what can we do? What kind of attacks can we do with our tool? So what's the reason? Why should one attack a routing protocol? What benefit does someone get out of the attacking a routing protocol? So to give you an idea about that, we will now have a short discussion of some of the attacks implemented in Loki. It's just not possible to cover all in this kind of time slot. So I don't know how deep you are into network protocols, routing protocols, whatever. So I will give you a short overview about that. Routing protocols in general are used between network routers to exchange information about their connected networks, about how they can reach other networks, how far the networks are away, for example, if it's a good option for another router to use this router to reach a network. So routing protocols do this dynamically, so they can act upon link failure. If an interface goes down or a line is broken, it can just switch over to another one, so the network's still reachable. There are 2 kinds of routing you can use. In small networks you can use static routes, but in large networks with several hundred, several thousands of nodes, of routers, of networks, you can't use static routes. That would be a really pain. So you need some protocol handling your routing information, your network information to get the stuff working. Unfortunately, the internet would not be working without routing protocols. So there are different flavors of routing protocols. First are the interior gateway routing protocols, or the interior gateway protocols, short as IGP. They're mainly used inside our so-called autonomous systems. So you will find protocols like this inside a corporate network, for example. Any scale of network can use these networks. One of the most famous of these kinds of protocols is the OSPF module. If you go to, let's say, 10 different big networks, you will find it at least 5, 6, 7 times using OSPF as a routing protocol. So inside corporate networks, inside closed networks, you don't communicate with interior gateway protocols, with other networks, with other domains, with the internet or whatever. The other kind of routing protocol are the exterior gateway protocols. There's mainly one exterior gateway protocol. It's called BGP. The internet uses it to exchange information about the connected networks, how they can be reached, where they are located, alternatives routes to that networks if one link fails. So that's the one you will find in the internet. Yeah? The internet routing stuff is handled by BGP. In some really large corporate networks, you can also find BGP. Some guys implement this also, or use it as kind of an interior gateway protocol and use BGP inside the corporate network. So for the routing protocols, there are different ways to do their work in general. So totally different categories, concepts behind these routing protocols. One of the oldest one is the distance vector routing protocol, or distance vector protocols category. Protocols like RIP, which is not used anymore, or really rarely used. And it's enhanced EIGRP protocol. The distance vector protocols mainly exchange information with their neighbor routers about how they reach which network. So router A maybe tells router B, I can reach the network 192.168.0 via 3 hops. 3 additional routers, it's 3 hops away from me. So if you don't have a better path to that network, just use me as your router. I will manage to get this network there, to get your packets there. So this is pretty much distance vector. Which network can be reached with what distance? How far is it away? So, the other ones, the link state protocols, these are, let's say, the newer ones, like OSPF or ISIS. They don't exchange information about all their networks they know. They just exchange information about their directly connected networks, which are not reached using another router. So they tell their neighbor, I have 1, 2, 3 links. There are these 3 networks, and these are my neighbors. So after the initialization of a link state protocol, it's a little bit simplified, but let's explain it on a small network. Every participating router knows the complete network layout. So they don't rely on distance information, but they know by their own, if this link is broken, I can reach that network over the other way also. So it's a complete different kind of routing protocol. They exchange link state information, who are my neighbors, what networks I am directly connected to, and distance vector protocols exchange information of which network do I know and how do I reach it, how far is it away. So different kind of information that is exchanged. A third kind is a path vector protocol that's used by BGP. I don't cover this here in detail because the talk doesn't cover BGP today, so it's not necessary. But it's a little bit similar to the distance vector protocol, just I don't exchange information about networks, but information about autonomous systems, which are many networks. Good. So that are the kind of routing protocols and the purpose of routing protocols in general. So why should we attack routing protocols? So what has already been done on the topic attacking or security of routing protocols? There have been a talk at the DEF CON in 2008 by Capella and Pilosov. There was a talk at the Black Hat 2009, that's the talk we just mentioned, it was about MPLS and BGP. There were some, let's say, incidents when something bad happens to a routing protocol. Let's say the YouTube Pakistan incident. Some of you may remember that. Pakistan tried to block YouTube by advertising the YouTube network inside the Iran. And that did some error, and it was advertised on the whole internet, and nobody could reach YouTube anymore. And there are also some other incidents when something get wrong with a routing protocol. Most likely there are human errors, what happened there. Also, there's not too much discussion about routing protocol security in general. There's an RFC, it's called Generic Threats of Routing Protocols, which covers, what bad can happen, the bad things that can happen to routing protocols. There's an IETF draft on OSPF security vulnerability analysis. There was a presentation about, with a proof of concept on attacking OSPF networks, also injecting routes, but it was, let's say, a small proof of concept program, which was hard to use in real attacks because it just worked in some special scenarios. And there's also an IETF working group. There was an IETF working group handling routing protocol security, but they concluded their work, I think it was last year, beginning of the last year. So that's pretty much the things that already happened against routing protocols.